Welcome back. So we've actually made it to Learning Module 7, which is our first mini project. It's not really a project in the traditional engineering sense of the word, but this set of programming practices for Learning Module 7 includes 5 more advanced programs that really require to apply everything we've learned to this point in the course. It's meant to be a challenge, so I do want you to set aside a bit more time than you have for the prior programming practices. I'm making this separate video to help with a couple of the examples, but there's really no separate set of slides to look for. There's no quiz for Learning Module 7. It's just the programming practices for this mini project. There are 5 different programs, as I mentioned, of pretty high level of difficulty. I don't really have time to go through all 5 of them and kind of explore them all. Of those 5, I guess I'm of the opinion that the Wordle example is probably the hardest one conceptually to work your way through. And the Powerball example is probably the hardest one to test of those 5. So one's got a little bit more conceptual difficulty than the rest, and the other one has a little bit more, I would say, testing difficulty than the rest of them. I'm in student mode here, so I can see it from your view of what you are going to be able to see as you work on this. It actually is a starter program that allows you to see what it can do for printing out the right squares. Conceptually, part of the challenge is if you don't know how Wordle works, you're going to have a very hard time kind of understanding what I'm getting at. I provided a link and say, hey, take a 5-minute rest and give Wordle a try. It's certainly okay to give Wordle a try. Everyone has their own approach to it. The idea is you have these 5-letter words. And with these 5-letter words, you get a certain number of guesses. And in this version, you get 6 guesses to figure out what the secret word is going to be. All of your guesses have to be valid words, or at least words that show up in the Wordle dictionary. And it will give you feedback after each guess based on how well you did on that guess. My son always likes to start with shunt, so we'll start with shunt as our first guess. It's a valid word, not a very common word. It uses 5 different letters, so it's a decent guess. And we get some feedback, and the feedback is none of those letters are correct. So that's that kind of gray or blank highlighting. This version also tells you which letters you've already used, which is useful. In our case, we know there is no S, H, U, N, or T in the secret word we're looking for. We're not in trouble, but we're almost in trouble. Another one, if you want to really try all the different vowels, is a do. I feel like that's cheating as a word because that's kind of a French word, but we use it in English. And now we've finally gotten a couple of letters that are actually in the final word. These are highlighted in kind of a yellow, off yellow, indicating they are in the word, but they're not in that location in the final secret word. So there is a D in the word somewhere, but it's not in the second location. So you know it's in 1, 3, 4, or 5. Likewise, there is an E in the word, but it's not in location 4. What's another one that we can try? We know there's an E. Well, no, that's not a great word because we already know there's an E somewhere else here. Let's give that a try, though. That's not a bad guess. And it turns out in retrospect, although you're probably going to watch me fail at this. Edges. We actually have 4 of the 5 letters correct, but they're all in the wrong location. So there's actually 2 E's, but neither of them are in the right location. So not the first letter, not the 4th letter. It's got to be the 2nd, 3rd, or 5th letter. We've learned there's a G, which is also not in the right location. Let's see what else. That puts a G elsewhere. But we know there's no S. We know there's no U. It's okay. We can keep guessing here. G is also not in that location. E is not in the 1st, 3rd, or 4th location. It's probably in the last location and 2nd location then, because there's 2 E's. They have to be somewhere here. Hedge. I'm running out of guesses. Hedge is a pretty good guess, but we know there's no H, so we know that's not correct. But we did get the right guesses, so cutting it a little close there. The answer is actually wedge. At least it better be. Phew, it says, isn't that great? With the feedback that green is for a letter that's both in the right location and is the right letter here. So for this Wordle example, after you've played a couple tries of Wordle, you get those 6 attempts to guess the word of the day, and our program is to basically create a C implementation of Wordle that, given a certain guess, you'll get feedback regarding how many of the letters are correct with white squares, yellow squares, or green squares for the corresponding case. And then you'll either get the 6 guesses and you'll succeed within the 6 guesses, or you'll be told, sorry, you didn't actually win here. And there's 2 example executions provided below. These test cases are a little bit more complicated than our other test cases, partially because we have to provide just both a random number so we can grab a different word each time, and we're doing random kind of guesses as well. But you can have a lot of fun with this program even without the actual random guesses. They could be actual guesses that you yourself can try, and you can kind of test yourself against with the Wordle once you've implemented it, kind of like an unlimited mode Wordle here. Key for understanding how this program is going to work are these 2 header files that are provided with your program. There is a list of valid words. This is the entire Wordle dictionary. We had that example in the previous learning module about the 2-dimensional array, right? Where 1 dimension was the number of words, that's our columns, and each row was representing a different word, right? And that's how we got our 2 dimensions. It's actually a little bit simpler than that in some sense for the Wordle dictionary, because the only valid words are 5 letters long. You can't enter in a 4-letter guess. You can't enter into a 6-letter guess. You can only enter in 5-letter words. It's a somewhat arbitrary number of selected words from a larger potential dictionary. I have it provided for you as an already initialized 2-dimensional array. You can just read this as one really big variable in your code called Wordle valid words. There's 12,972 of them. Each of them are of length 6. Hey, you just said length 5. That's including that null byte, right? So we're also including that null byte. They're valid words. You can run string comp. You can run other things on them. There's also the list of answers of the day, which is actually a subset of the total dictionary. Some of those dictionary words are pretty obscure. People would be very unhappy if the word was Ali, as a dictionary, as an answer word. But these are the potential valid words of which there's a subset of that larger dictionary. So Wordle's going to repeat itself roughly every 2,000 days here because of the number of words that are valid. This is straight from the source code for Wordle that's publicly provided. So you're actually, as you're implementing this, you're implementing as real a Wordle as it gets when you do this. The starter code just kind of shows off a couple things, how you can access the individual words in that array, although I think we already know that given the example we did last learning module, and also the kind of wacky Unicode printing. You can treat those Unicode strings as just C strings. The length of them is a little arbitrary sometimes, but if you just do %s, you can print out those values as expected. This is actually going to be a lot of printing because it's printing out the entire dictionary, and then at the very bottom, it's finally printing out in 2 different methods, the green, yellow, or white. So these are a good just kind of starter code. I say delete once ready to get started. Just keep it there. What's the harm, right? Keep that code there. It's not hurting anybody by being there, and we can kind of start our code up above. It is requesting a seed value. I would rather just, instead of entering it, let's just do seed equals, 10,000 as the example that's provided here. You're going to want to query the seed value, do a scanf for it. I don't care about it. I just kind of want to have repeatable tests that I can do here. And then you get up to 6 guesses, and there's characters in the guess array here, but then there's also some sort of like guess count that we want to be doing as well, right? So that's my next thought of, we have some number of guesses and we have the actual like text for the guess itself. I was just thinking that, I don't like to go straight to the code, and that's what we're doing here, but that's okay. But we have some variable called guess, and the main loop for this is going to be, for guess num equals 1, guess num less equals 6, and guess num plus plus. We could do 0 less than 6, and we just add +1, but it does start with guess number 1, then guess number 2, then guess number 3. But I do think we should go back to the whiteboard for this one. For guess number 2, the guess was shunt. The actual answer was story for that. Let's take a look at that. We have the actual guess was shunt. And the actual answer is story. And for that prompt, what we should be doing then is first detecting are any letters in the exact right spot. I think we'll see we can't use string comp and other functions to do that for us because that's checking the whole string. But checking if a value in one array is the same as a value in another array is something we actually already know how to do. No, that's not going to work. Let's just get rid of this whole concept. Okay. This one should be green. Maybe I can just move it underneath as opposed to on top of it here. And then the T would be the yellow example because there is a T in that word, but it's just not in the right location. And for the rest of them, it should be white. There's no H, there's no U, there's no N. I would guess my thought would be is implementing this. The green guesses aren't going to be that bad. If guess location is equal to answer location, they have to be equal to each other for it to be green. Likewise, the white ones, the ones that don't match anything, yeah, I'm not saying they're going to be easy, but we should be able to find those, right? The letter H is not in that word. We check the letter, check the entire word. It's not found at all. That's a miss. That's a word not found, right? I mean, I think that is something we should be able to do. The yellow ones are going to be tricky ones for this because for the yellow ones, we have to make sure it's not already a green letter. We have to make sure, if the guess was stunt and not shunt, only the first T should be yellow, not the second T, because there's not two T's in the answer. There's just a single T in the answer. That part's a little bit tricky. But as we make our guesses here, we should be able to figure out the green ones at the very least. First off, and we kind of have the code here for SRAN seed, and we can print it out even though that's not correct. Today's Wordle world was, that code's provided, let's use it. SRAND of the seed. Our answer index, which needs to be something we actually declare, some integer, is the random number mod num Wordle answers. I'm kind of just telling you that's how you have to generate the word for this. There's no like reverse engineering of what I want, but you have those constants to kind of either iterate through or detect which one is your starting word. In this case, you're supposed to randomly select it just by doing rand mod number Wordle answers. Today's Wordle word was story. Okay, that's not quite what it should be printing out in terms of, when you get an incorrect result. But that at least knows that we've actually grabbed the correct word, or we can access the correct word. It's Wordle answers of answer index. We could copy that to another string if we wanted to just have it, handy. Car answer 6. That's a hard word for me to spell. Answer index, IDX. And it seems very unhappy about that, but that should be okay. That's today's answer. So we have that. That's correct, but we can just copy it into another variable so that we don't have to worry about accessing it via that index, remembering what the name of that index variable. It's a one-time thing. We also want to kind of keep track of the guess, and that's something we don't know what the guess is yet, but there is going to be some sort of guess. That's what the user is going to be typing in. We can write at least that block of code, guess number 1, which is what the prompt is, right? Guess number, not 1, but %d. Here's our printf scanf loop. Scanf, %s, and the guess. That is the user's guess. Let's confirm. You guessed. Guess. It's not part of the spec, but it's fine. Too few arguments to function call. Yes, absolutely. When we do string copy, we don't return the string as a result. We actually separately call string copy and have as the destination the name of the string we want to overwrite. Today's Wordle word was story. Let's get rid of that for now. Guess number 1, adieu. Close enough. You guessed adieu. Okay, fine. So we are grabbing the guess. We have that much working. You guessed adieu. Now what? Can we detect whether this was even a valid guess, right? Right now, I could type in whatever I want, right? And it would think that that's a valid guess. But for it to be a valid guess, it would have to be a word that's considered a valid word in this list of valid words. Was it a valid guess? Check against. This is kind of going to be an expensive operation in terms of the amount of computation we're doing here. Do we have a valid guess? Let's assume by default we don't, and prove to me that we actually do. How many words we have to check? We could do so alphabetically, but really got to check all of them otherwise. It's a valid guess when it actually shows up in the list of words. Now, this should look pretty familiar compared to the logic that was checking if we had a matching or duplicate word here. We could maybe lower the guess to lowercase, but I don't think we have to because none of the tests are requiring that. If we actually did that, string comp guess Wordle valid words, it matches one of the words. Yes, it is a valid guess. We don't have to check anymore. Hey, we're done. We match the word. We do not have to look anymore at that word. I have to keep looking at the spec here, as well as for the tests. I don't think any of the tests are actually doing, 1,000, but it's not doing like capitalization or things like that. So it'll just say if you did capital adieu, it'll tell you that you don't have a valid word. That's just how the tests are being created. So that's okay, but if valid, okay, we had a valid guess. Or perhaps if we didn't have a valid guess, because if we have a valid guess, we should continue. If we didn't have a valid guess, what should we do? I want you to think about that. I don't want to necessarily say what you should do, but you should definitely, what was the printout in one of the test cases here? Not a valid word. I mean, that much we can do. Not a valid word. Please try again. That's fine. Looks like before we do any of this kind of printf, we add an extra new line there. That part's easy enough to add. Not a valid word. Please try again. We got to be careful with our guess num. Got to go back to the previous guess then. Break would break us out of the loop. How do we continue the loop? I'll let you consider that. There is an answer to that question. What keyword would make sense for that? Now, can we check, any green letters? And I guess we need to have some way of storing the actual results, whether that's like an integer or a car. I mean, int is fine. And there's just 5 results, right? Because it's just for the 5 letters we guessed, we'll initialize it to zeros. For the 5 that we guessed, are we correct or not? We could define miss as 0, pound define. I don't think we can call it yellow. Close. We don't have to do this. We could just use any other constants we want. But do we have any green letters? Well, we'd have to actually just check all of the values in that string, right? Do we have, and here it's hard-coded. It's always going to be 5. It's always a 5-length Wordle. By default, it's a miss, but if in our guess, if that letter is equal to the answer of I, then results of I equals match, assuming that's the case. We've done our guess. We've checked if there's any green. We can kind of think about like how we would print that out, right? We have that results array that says whether it's a miss. We haven't done anything for close yet, but we can certainly check it. We can print the actual guess again. Because it's printing each letter with a space, right? So let's do the actual individual guess letter. And then afterwards, we're going to print out for those individual characters, was it a green or was it not? So that's another loop through the same array, basically. If the results, I'm going to scroll down a little bit here. If the results of I equals match, we should print that green macro. We were doing it with %s and then green. That should work. there was two ways we did to print it. Either would be fine. Else, if results of I equals close, print something. And then else we didn't match. And that is at the end of a given guess here. This code is getting a little long. And it looks like we have new line, now it's the next guess. Let's give it a go. Error, unterminated macro-like function. Oh, well, I got a little sloppy there. There we go. It's a funny error, right? Because it happened to be in a macro, it didn't really tell us what the error actually was. Adieu. Oh, well, shunt. We got one green. What was the actual word? So let's do stone, 3 greens. So our green process is pretty good. Of course, we guessed it correctly with story, and it's not capitalized, and it's not fully correct. But that's pretty good progress on that one. I mean, I don't know. You're like 20% of the way there. The greens and the whites are pretty straightforward. By default, everything's a white, and then you determine if it's a green or a yellow. Green, we basically did. Yellow, you have to kind of think about because you have to watch out for double counting and things like that. Get all your printf syntax correct for that example, which I didn't quite do, but we got pretty close to it, so that when you do run the test cases, they give you some useful feedback. Here, the feedback may or may not be useful. Let's take a look at like how close we got. Right? This is how I want you to interpret these tests, and I know you've been doing this all semester already. Here's what the expected output should be. And I think because we never entered in a seed value, it's going to be pretty cranky about it. Yeah. So I would argue to even get to a point where you're doing anything interesting in terms of checking your test results versus just testing it for yourself. Where's that seed? We have to actually do that print prompt. I mean, it's fine for testing it yourself. It's still correct, but the automated tests are going to really choke if they're missing a whole line of print and a whole thing of input. So let's try it again. Still going to be a fail, obviously, because we haven't finished the code. Actual output, pretty useful, right? I don't know. I feel like that tells me something. I mean, looking at this, it says, hey, you really need to capitalize when you're printing out those. We can do that. It's showing crossing out the lowercase a, and instead you're supposed to be printing out uppercase a. I think we know just the function for that. Likewise, it's wrong because it printed out a white when it should be yellow. Well, yeah, that's fine. And our actual guesses are different, so that would be the other thing. Oh, no, our guesses are the same. This is the automated test case. It's getting the greens correct. It's missing the yellows. And then, of course, it's not determining that we've actually finished or not and doing that finished condition. Maybe I'll up it to 40% done, but the extra 60% is still pretty darn challenging, and I hope you look forward to working on that. So we're masters of Wordle. I wish I could show you an equivalent case where I'm actually winning the Powerball like I was winning Wordle, but at least we can take a look, at least briefly, at the project and the specifications for that. Here, I think the important part and the tricky part are the test cases themselves. I wouldn't say the logic is that bad. You have to make sure you're generating the random numbers correctly. So I would like us to at least generate a couple of the random numbers correctly so you're not, totally stuck with how you're doing that kind of work. But the issue is the test cases themselves are quite challenging because it's simulating playing the Powerball over and over and over until you've lost $10,000. And that's going to take more than 5,000 plays because you will occasionally win these smaller amounts and earn more money to buy more tickets. So the issue, if you look at test this one, is early big. The only actual input, and this is the test result, you should be able to see the actual input, but it's way down here. So that's a lot of things, and obviously with that input you can test now, but when you get it wrong, it's going to be all just full of red diffs. That's going to be a pretty hard thing to debug. So really, I think your best bet is going to be to debug, the first year of simulation of the Powerball. And if you get that right, I think there's a high likelihood that you're going to get the rest right. But some of these are going to have some subtle bugs that are only going to show up in year 7 of simulating it. So logically, I don't think it's as hard as doing the yellow cases for the Wordle. But testing it's going to be a little bit of a pain, I think. Part of it is the spec. So for the random number generation, we really have to do and take care of 2 different things. First, we have to pick the actual ticket numbers. Here's my lucky numbers. That's 5 numbers and a Powerball. The 5 numbers are in the range 1 to 69. The Powerball's in the range 1 to 26. We then have to actually generate the drawing. What was the actual result here? For both those cases, what makes it a little bit trickier than some of the other random number generation we've already been doing is we can't have any repeat numbers. And if you generate, 5 random numbers in the range 1 through 69, there's definitely a possibility that you're gonna repeat something. And Powerball has this like physical drawing of numbers. Once the number 17 has been drawn for that given drawing, you can't draw it again. Likewise, your ticket can't have repeated numbers for that reason. So some of the logic is okay. So in terms of our knowledge of how we've been generating random numbers, we can figure out ticket of I. And it did say, I'm pretty positive we have to be careful about this because the way random works, if we do it in the wrong order, we're going to get totally different results. So both the numbers for the ticket and for the drawing are generated using rand, limited to the range described above, and the numbers cannot be repeated. So 1, 2, 3, 4, 1 is not a valid drawing. I had certainly had to have said it somewhere that you have to actually do the ticket drawing first. It's here in a comment. If you did it in the opposite order, it just wouldn't work, to be frank. So ticket of I for the first 5 numbers, we want a number in the range 1 through 69. This doesn't quite work. That's 0 through 69. This doesn't quite work because that is 0 through 68. But if we're generating a random number in the range 0 to 68, we can just add 1 to it, and then we have a random number in the range 1 to 69. But we have to check. We definitely have to check. And I'll also leave a comment here, kind of similar to what the Wordle example was doing, where when it was an invalid guess, we kind of go back and we have to break that loop or continue that loop. So we have to have some logic, is this number already on the ticket? If so, regenerate. It's not going to happen that often, but over like the years and years of Powerball drawings that you're doing, it is eventually going to happen. Likewise, we have to generate the actual Powerball. I would leave a comment there. Generate the Powerball ticket of 5, which is the Powerball. In this case, the 6 number. It's between the range 1 and 21, so you can just do something very similar logic-wise to generate that Powerball value that you have there. You also then have to do the Powerball drawing. It should be pretty similar, almost copy-paste. And then we actually have to check the results. And checking the results is a little tricky, but it's not as hard. I would say, this is similar to, but easier than Wordle checking, because while we can have the match anywhere in those, first 5 numbers or the Powerball itself, the order doesn't matter for the Powerball ticket. So if the Powerball drawing was 5, 4, 3, 2, 1, and your ticket said 1, 2, 3, 4, 5, there's no requirement to be ordered here. You still win. You've gotten matches. So we're really just counting yellows or just greens in a sense. Just count matches and Powerball matches. And that code should be okay. And then we have to kind of figure out, based on how many matches there are, how many, whether you have the Powerball match at all, how much additional money you should be adding to your current amount of money. This can be a case statement, or this probably more likely just a set of complex relational operators. If you get that right and you get the actual printing, kind of precisely what it is here, I think you'll make pretty good progress on this example with some subtle things that are here. It requires that you print out every time you win more than $10, but for debugging, you should print out everything to begin with. And then once at the beginning of every year, you should print out the balance as well as the first drawing of the year. We have to be a little bit careful what we're defining years as. We're starting the day on day 1. So day 1, we always print out. That's good for debugging. Day 366, we also always print out, etc. For the next one would be day 731. I think that's correct, would be the next one that we would then print out. We're adding 365. We have to check that condition as well. The simulation can go on for decades for some of these examples. So it's hard to test it in that sense. You have tens of thousands of lines of output. You need to be exactly correct to get the right result. If you do things in the right order here, if you check that things have already existed on the ticket and then regenerate in that order, you should confirm that you're getting the same exact tickets and drawings as the test cases, and then I think you'll be able to implement the rest of the logic from there. That's just some really kind of basic pointers, but that's all this learning module is getting you started on these projects. I believe in you. I know these are tough, but I know you can do it too. So good luck. Please reach out for help on these. Um, they're not easy, and I want to see a lot of successful projects. So good luck to you.